In this part of chapter 8, we're still multiplying polynomials, but specifically in this one, we want to introduce a couple of different methods. So in the previous lesson, we were multiplying a monomial, one term, into a polynomial, more than one term typically. Today we want to look at the FOIL method, which we'll use specifically for binomials. So if I have a binomial times a binomial, the FOIL method is one of the ways that I might use to distribute, to multiply polynomials. Or I might, if it's not two binomials, or even if it is two binomials, or I might use the distributive property to multiply polynomials. So let's jump in here and do an example, and you'll see what I'm talking about. So this is a binomial times a binomial. So we have two terms and two terms. And notice that there's nothing between those two parentheses, so there's no addition or subtraction. So we assume that this is multiplication, right? So using the distributive property, what this says is the 2x plus 3 wants to be multiplied by the x plus 5. In other words, the 2x wants to get multiplied, okay, and that looks like this. And the 3 wants to be multiplied, distributed. So there's our plus 3. It's a positive 3. And it's going to be distributed to the x plus 5. And then this is one of those intermediate steps that some of us will skip this step eventually, but I want to show you, I want to make sure you see what's going on. So the 2x is wanting to get into the parenthesis, and the 3 is wanting to get into the parenthesis. And so this is what the distributive property looks like. Now, it's very similar to a problem that we did in the previous part of this chapter, where a monomial wanted to be multiplied times a polynomial. And we did that twice. So this is not a new thing in and of itself. How we got here, how we started with two binomials and ended up with a polynomial times a binomial, that's a little different. So the 2x wants to be distributed, and the plus 3 wants to be distributed. So let's do that. 2x times x is 2x squared. 2x times 5 is 10x. 3 times x is 3x. And 3 times 5 is 15. If there are terms that we can put together, this is the place that we would do that. And what's typically going to happen with these binomials or polynomial multiplication is there are going to be terms that can be added together. And so in this case, we would end up with 2x squared plus 13x plus 15. And this would be not only the multiplied form, the distributed form, but this is also standard form because of the decreasing order of degrees. All right. So you try one, and we'll check your answer when we're done. The x wants to get distributed, and the minus 2 wanted to be distributed. So 3x squared plus 4x minus 6x minus 8. The middle terms are going to come together, and you should have 3x squared minus 2x minus 8 as your final answer. All right. So another way that we might think about multiplying binomials, and this method specifically works with two binomials. We will not do what we call the FOIL method. That's what this is, the FOIL method. We will only do the FOIL method with two binomials. But here's what the FOIL method says, and it's one of those shortcuts that we use to not have to write everything down. But it says to multiply two binomials, we find the sum of the products. So we're going to have to go do the products and then add them together, but we're going to find the sum of the products of the first terms, outer terms, inner terms, last terms. So there's your FOIL, F-O-I-L, first, outer, inner, last. And here's what that looks like. X plus 4 is being multiplied by x minus 2. So your first terms are your x and x. So they're going to get multiplied together and to get x squared. Your outer terms, the x and the negative 2, got multiplied together to give us negative 2x. Inner, 4 times x is 4x. And your last, 4 times negative 2 is negative 8. And then, again, if there are terms that can go together, we'll put them together. And in this case, the negative 2x's and the positive 4x's can go together. And we have a positive 2x in the middle. So that's the FOIL method. First, outer, inner, last. And even with this method, like, you'll still end up doing it a little quicker and showing a few less steps than even this. Okay, so let's jump in and let's do one. You've seen one, so I'm gonna give you a chance to do this first one, and we'll check and see. We'll check and see how you did. First times first, x squared. Outer, negative 4x. Inner, positive 3x. Last, negative 12. The middle terms combine, x squared minus x minus 12. Okay? So sometimes though, and distribution worked with binomials, FOIL worked with binomials. Sometimes though, we have to go back and just do the good old tried and true distribution. A binomial times a trinomial, like the 3x minus 5 wants to get distributed. Okay? So the 3x wants to be multiplied by 2x squared plus 7x minus 8. And the minus 5 wants to be distributed to the 2x squared plus 7x minus 8. And I'm writing all of this out, writing it all out. Maybe you will, maybe you won't, but like, you're still going to have to keep track of what you've distributed to what. So get a pattern, get a rhythm, and make sure that the 3x is being distributed to everything and the minus 5 is being distributed to everything. So one of the things I want to slow down and show you here though is what we call the stack method. And it's not really a different method of distributing. It's a different way of maybe organizing our product as we work through the problem, so that when we get done, like, it's going to be easier to combine terms. So let's start with, we've broken it up into two pieces, right? The 3x is going to be distributed into the parenthesis, and the negative 5 will be distributed. So let's distribute the 3x, right? So 3x times 2x squared, 6x cubed plus 21x squared minus 24x. All right, so we've got the 3x distributed. Now let's get the negative 5 distributed. Okay, so negative 5 times 2x squared, that's going to be negative 10x squared. Now here's what I noticed. I already have an x squared term in my product that I'm going to be adding together here in just a minute. So instead of writing it out here and then in my next step trying to find all those x squareds, I'm going to stack. I'm going to go ahead and group the terms together that need to be grouped together, so that in my next step I can just combine them. So negative 5 times 2x squared is negative 10x squared. Negative 5 times 7x is negative 35x. And positive 40. Okay, so you'll notice all of our like terms got stacked together, and so now we can just combine them. There were no more x cubes, so there's our 6x cubed. The 21 and the minus 12 leaves us with a positive 11x squared and a negative 59x and a plus 40. And so everything that can be put together has been put together. And you'll notice that we ended up in standard form, right? So we started in standard form, and then as we work, we kept it in standard form. And so when we're done, we're still in standard form, okay? Now, I'm not going to do this one here, but I want you to do this one. And I want you to bring this one back to class. Now, notice what we've done though. We've just gotten a little larger, right? We've got a trinomial times a trinomial. So this, all of these pieces, the 2x squared wants to be distributed, the 3x wants to be distributed, the minus 1 wants to be distributed. And sitting here, I think I've changed my mind. I'm going to go ahead and work this one now. So pause the video, or maybe it's going to stop on its own, and see what you can do with it. I'm going to do it stacked method again. I'm going to skip that intermediate step where I'm rewriting the problem, and let's see what happens here. So the 2x squared is going to get distributed. So we're going to end up with 6x to the 4th minus 10x cubed plus 4x squared. The 3x is going to get distributed, and I'm going to go ahead and stack. I'm going to stack the things that look alike. So when the 3x gets distributed, there's a 9x cubed minus 15x squared plus 6x. And notice how our terms are stacking up. The like terms are stacking up. Now, negative 1 has got to be distributed. So that's going to be a negative 3x squared. And again, I'm stacking like terms, plus 5x, and then minus 2, and there are a little double line there, so we can combine all the things that are combinable. 6x4 is just all by itself, minus x cubed. Now we've got a positive 4, a negative 15, and a negative 3. So when all that gets combined together, we should end up with a negative 14, and the x squared doesn't change, plus 11x minus 2. Everything is combined together, and I'm still in standard form.